if you want the best casting possible, you have to increase the solid fraction. That's a statement. I started my presentation in Aalen, and I want to start this presentation now in English as well. So let's just jump into it. Here on this picture, you can see the Rivian hinge pillar. It is produced by Dynatool in Canada, and it's the world's most sustainable casting. The alloy used has only 0.136 kilograms of carbon footprint per kilogram aluminium. For that part, we have a deeper look into it. Here you can see the Rivian hinge pillar with just 20% of solid fraction for the slurry. You can see the blisters like you know it from high pressure die casting, and they're quite huge after T6 heat treatment. The same part with the optimized parameters at 40% solid fraction. You cannot see any blisters anymore. Why is that? Because the high solid fraction has the effect that the speed for laminar filling increases. So with a higher solid fraction, we can cast at a higher speed, filling the part more quickly, still maintaining a laminar filling without any turbulences. That creates a better casting quality, as you can see in the picture here. Going higher, you will reach eutectic swamped areas that are still producing porosity again. Another claim is to make that a high solid fraction and a smaller die casting machine are a double shot at cost reduction. Here I can show you. That's the projected area of the Rivian hinge pillar in between here with a high pressure die casting in-gate system and overflow system, optimized for the shortest way possible. If you calculate that for high pressure die casting, it's 2,800 tons of clamping force. Let's have a look at the same in-gate system for Rio casting. It looks way smaller. It's just 50% of the high pressure die casting in-gate. You can see a central in-gate and two overflows with the long flow length in between. This results in 1,650 tons of clamping force, mainly due to column distance to get a part out of the tool. Now, let's transfer that knowledge we just gained into giga castings. We have several categories, and I also calculated the impact on the part price. First of all, let's look at the machine size. High pressure die casting, 8,400 ton for giga casting. With a Rio casting, we're looking at 6,100 ton machine. Usually there's 30 to 40 to 50% of reduction. This results in around €7 per giga casting in savings. The next thing is the major thing. Usually we end up with 70%, 75% longer die lifetime due to colder temperature and lower speeds. This is about €43 per giga casting in savings. If you look at the longer flow length, we can reach up to 76% longer flow length due to the pocket warmer effect. And with better feeding, you can reduce the wall thickness up to 50%. With the material saving, that's another €22. When the EU starts to implement taxes on alloy imports, then there's another €18 savings just by reducing the weight and reducing the carbon footprint. If you sum it up, it's about €90 of cost saving for just one part. Not included is that smaller tools for smaller machines are cheaper. The energy costs of a much smaller machine are also cheaper, and the repeating PPAP costs are also way more expensive. That's all you can save, and you can increase that number even further. That's the end of my presentation, and I want to end it as I started it with a sentence I like to discuss with you in the comments. Silicon is the biggest CO2 driver in sustainable castings.